Good afternoon, everyone. Am I audible? So, why the strength of student is continuously decreasing? Did you have any campus talk or placement talk today, or some event? I thought some of you might be in event. Or was there anything scheduled today? Why the strength is very less? I see only 64 students online. Yes, let's wait for some time, maybe 1 or 2 minutes, and ask your friends to join, and then we'll begin. We are almost done with the syllabus, but the things that we are going to discuss now is very useful. So please pay attention. Yes, I will share my screen. So we have 2, 3 lectures more. But at the most, I think 4 lectures we have to discuss some advanced topics. And as you know, we covered the core content of the syllabus a bit early because we wanted to discuss about this. So we'll start with a very interesting topic called deep learning, which is very popular these days. Many of you might already be attending uh, online lectures for deep learning or might be participating in some competitions like Kaggle and other machine learning competition where deep learning models are predominantly used. So we'll spend 1 or 2 lectures to briefly discuss about the deep learning models, and also we'll do one laboratory to get your hands dirty and get an idea of how you can do this. And I think this is right time that we are ready to discuss about deep learning also. So I will also give you a brief context of where we are and what we are looking at. So I think you have studied support vector machine, right? Just to make sure that you know the basics required. You know support vector machine, and you also know feed forward neural network. or as they say MLFF, and they often say it is MLFF with BPN. Do you know what is this MLFF with BPN? Full name of what is MLFF with BPN? Who would answer this? Priyank says perceptron. Okay, yes, it is perceptron. So neural networks, which for which the basic unit is a single neuron, which is modeled after perceptron. First says, I guess, multi-layered feed-forward network. Yes, multi-layered feed-forward network. And what is BPN? Yes, Shale has the right answer. Multi-layered feed-forward network with backpropagation algorithm. So I just wanted to make sure that whether you have done this or not. I believe the backpropagation algorithm is covered in the class, right? So can someone tell me the basic difference between the support vector machines and feed-forward network? So before that, uh, the primary question is, are they competing models or they are that competing in context of application? So can you solve the same problem using SVM also and feed-forward neural networks also? Or these two are completely different models made for different purpose to solve different problems? So are these two models competing in terms of their applicability? SVM and multi-layered feed-forward network. I'm asking between this. Priyank says different, so they have different applications. Okay. Is there anyone who thinks that they are replaceable, like one can be used or one can be used in place of another? So, okay, let me give you some idea. But before that, confirm SVM is done, right? SVM and this feed-forward network both are covered in class, right? I think Lakshmi madam has done this. So one is both are classifiers, right? Both are classifiers. And second is, are they generative or discriminative? What is your take on this? Are they generative models or discriminative models? They are discriminative, right? Since it's discriminative, yes, because you try to draw a separating boundary. So I will try to, or I would ask you to investigate on this based on separating boundary or hyperplane. And I think you also know about separability, don't you? What is linear separability? So you try to draw a line between positive and negative examples in case of binary classification. That is called linear separability. That we have discussed in the context of support vector machine also, and that you have discussed in context of perceptrons also, haven't you? Please confirm me because we are trying to think here. So if you do not know anything or if you have any questions or if you have any disagreement, please message here and please pay attention because the things that we are going to discuss are very useful. So there is a idea of linear separability where you want examples to be linearly separable, means that you can draw a line between the two different classes of the data points, positive class and negative class. If the linear separability is satisfied, then you can do it through classification of perceptron. A single perceptron can do the classification, or support vector machine can do it. And in context of support vector machine, we talk about the max margin classifier. We want the margin between the two data classes to be as large as possible. So a classification problem is converted into an optimization problem where you want to maximize the margin between the classification boundaries. The boundary that you draw between the data points, you want to maximize that, right? Something like this. If the data points are like this, then in case of SVM, you try to draw a line which is as far as possible from both data point boundaries. And you want to maximize that. We want to maximize this margin. So this is called max margin classifier, support vector machine I'm talking about. Support vector machine maximizes the margin. The SVM is called max margin classifier. And by posing the problem like this, SVM converts a classification problem into a quadratic programming problem. This problem is proposed as a quadratic programming problem. And using the Lagrange's multiplier, this is solved using the quadratic programming technique. The linear programming which you have used in your algorithm, advanced algorithm course. The similar approach is there for quadratic programming also, and with that approach you can solve SVM. I think I will not go into the mathematics of this all over again because it is already covered. But in context of our discussion, I would say that the multi-layered feed-forward network and support vector machine both can perform the same task, but their way of performing is completely different. In case of multi-layered feed-forward network, we do an error correction kind of model. Like you calculate the gradient and do a gradient descent technique. Through gradient descent technique, you can optimize the weight value so that the error is minimized. So that is a feed-forward neural network, which is a which works on error correction. So the differentiating factor between these two is MLFF learning is through error correction, and the popular technique is gradient descent, on which the backpropagation algorithm is based. In case of SVM deals it as a quadratic optimization problem. So it maximizes the distance of data points from the separating line. So this is the differentiating factor, but otherwise they are interchangeable techniques. So out of these two, if we want to draw a line between the data points, which one would draw a better line? Multi-layer feed-forward network or support vector machine? What is your answer for this? Okay, so we have different answers. Priyank says MLSS, Prince says SVM. Okay, so one thing we need to understand is that SVM is an optimization problem. So it guarantees that the maximize the distance of separating point from the data, distance of separating line from the data is maximum. Right? So SVM guarantees that. MLFF does not guarantee that. MLFF says that I will minimize the error and draw a line passing through the data point, which can do the classification. But it does not guarantee that the line that you are drawing is farthest from the data points. So in that sense, the answer of Prince is correct, that SVM guarantees that the separating hyperplane is far from the data point, so classification would be better. And this is how the history of machine learning has evolved. As you know, in late 50s or early 1960s, perceptron was proposed by Rosenblatt, and when the perceptron was proposed, it was viewed as a groundbreaking research. And people have started imagining the hardware devices or the processors where the single unit of processing is a perceptron. So you can that you can write through perceptron. So people have started imagining that the perceptron can be part of a hardware circuit which makes an intelligent processor. That was the idea conceived with the invention of perceptron somewhere in late 50s or early 60s. But then perceptron hit its limit very soon with this problem of linear separability, and people realized that we need more than one neuron to find the separating hyperplane. Not just more than one neuron, but also more than one layers of neurons. And this is where the idea of multi-layered feed-forward network came in. And again, somewhere in late 70s, backpropagation algorithm, somewhere in late 70s, backpropagation algorithm was proposed. And this multi-layered network, which can learn any nonlinear function, became very popular. So that was the idea of multi-layered feed-forward network. something like this, where you can do the layers of neurons, and you are getting some function x1, x2 up to xn, and you are getting output of yn to yn. And through this backpropagation idea, you can say that you can learn any nonlinear function y is equal to fx, where x can be a. Now, can you tell me where this nonlinearity is modeled in this network? If the neurons, the perceptrons are linear, right? We know that perceptrons are linear, and only operation that perceptron can perform is summation. Since the basic unit of processing is summation, how this nonlinearity is managed through multiple layers? The answer to that is the nonlinear activation function. You apply nonlinear activation function. Like sigmoid or tangent, hyperbolic tangent. So you give the input x1, xn, pass it through some nonlinear activation, and it goes to next level. So what goes to the next level, that middle level, it becomes non-linear. So this is where the non-linearity comes in. And this non-linearity is modeled through a layer called hidden layer. Layer before that was input layer. And layer after that is called output layer. So this nonlinearity is modeled through hidden layer. And then again, in early 80s or late 70s, the neural networks become very interesting thing, where people have started solving many machine learning problems using neural networks. And particularly through this multi-layer feed-forward network models, which uses backpropagation algorithm. But after that, in mid 80s or late 80s, SVM was proposed. SVM came to the fore, and SVM has guaranteed this max margin. The SVM came with the idea of max margin. So there are two benefits. One is you don't need to go through the error correction training, since it is a quadratic programming, where you don't need to iterate through the loop and randomly initialize weight and iterate through the loop and define the learning rate. All these things are not required. So it does not go with this error correction thing, but it directly attacks the problem as a quadratic programming problem and gives you the solution. The solution which is guaranteed to be the optimal in terms of the difference of separating plane from the data points. So HVM became very popular in late 80s and early 90s. And if you see the papers of machine learning in this era, up to early 2000, early 21st century, I would say, then most of the people have used support vector machine. And then there are many improvements on support vector machine in terms of kernel functions and to add the nonlinearity in the support vector machine. People have started exploring those ideas, and support vector machine was probably the most popular machine learning model to do this discriminative classification. Face recognition and many other problems were addressed through support vector machine. In 90s up to early 21st century. And the neural network has taken back seat for one more reason, that is the number of parameters that you need to deal with. As the size of input grows, in a fully connected network, your number of weight parameters that you need to be trained is very huge. So the training time, training cost is very high for neural network compared to SVM in those days. So that is also why the neural networks become a bit has taken a bit backseat. But then in around 2004, 5, 6, the Google came up with this idea of deep learning, where they have trained the models using multiple hidden layers. So that was a groundbreaking idea in early 21st century, where you train through multiple hidden layers. Up to that, people thought that only one hidden layer is sufficient to model any nonlinear function, because multiplying a nonlinear with a nonlinear does not add anything, does not improve anything, right? So in that sense, the neural networks of multi-layered networks of 20th century, more or less people agreed that one hidden layer is sufficient to model any kind of nonlinear function. But at the turn of the 21st century, this Google team has introduced a new idea, and that's why I believe that the probably this is why the name is deep learning, because you are learning deep through the layers. So usually it is much more than three layers. You're learning much more than three layers, and that's why the model and so in this case, the traditional multi-layer feed-forward network, we say that as the input size grows, weights to be trained also increases. This is also the problem with support vector machine, because in support vector machine also, uh, as the size of input grows, the machine it takes a lot of time to be trained. So this is a common problem with feed-forward neural network and support vector machine both. So in those days, late 90s, people used to do dimensionality reduction, where they do feature engineering to reduce the number of features to limit the size of input. And also, when the features are optimized, and if you further need to reduce the input size, apply some dimensionality reduction technique, as we had seen, like PCA or LSI or something like that. So those that was the practice in up to early 21st century. But then with the turn of 21st century, the processing capabilities of the machine has also increased. Right? We have now very high performing processors. Actually, Apple has now launched this neural engine processor with neural engine. So very powerful processing devices have came into existence. The idea of big data, cloud, or parallel processing and distributed computing has been reality in practice, and people have started using a cloud of multiple processors to do their task. So that is also why this is another stream of thought from where deep learning idea could be realized. People say that okay, now the huge number of weight is not a problem for us, so we can manage because we have space and we have processing capabilities. So they have introduced this idea of deep learning where uh, machine can have more than three layers, and then they said that okay, don't do this feature engineering and dimensional reduction and anything. Just give us data. We will make a huge network of neurons, thousands of neurons spread across many layers of the network, and they will learn the features, they will optimize the dimensions, and they will finally give you the output that you want. So that was the idea, and that idea, as I said, could be realized because the processing capabilities have improved. So in deep learning, the idea is more than three layers, and network can learn, or we believe that network learns important features and make accurate predictions. This is what we believe. Network can learn important features. So this separate layer of feature, separate exercise for feature engineering, feature dimensionality reduction, all this is not now required. We believe that use huge data, network can learn. And also the size of data is also increased. So can deal with. Right? So now nowadays we are also talking about big data in other fields. So when you go into your final semester, seventh semester, you will learn all these subjects, big data analytics. In that you will also learn about distributed computing, then AI model, cloud computing. All this will be your choices that will be offered to you in seventh semester, and you will learn this. And that's why this discussion and this course was important at this stage, so that you can get the broad picture of where we are standing. So deep learning models are primarily models which can deal with huge data sets, can train millions of neurons with that much amount of weight it can train. It can do the feature engineering for you, and it can make accurate production predictions for you also. That is the idea. Right? So I will stop here for 1 or 2 minutes, and please ask me if you have any questions or any doubt on this. Any questions, any comments, any doubts? It seems everything clear. Can someone confirm? Okay, Priyan says yes. Okay, good. So, yeah, so that was the story. That is the story of overview of the field, where we compared the feed forward network, SVM, and we motivated for deep learning, and we say why the deep learning is so popular these days. So the two very basic architectures which made deep learning popular, will introduce those two architectures today lecture. So that the first which was mentioned as Google model, which is called, and the second popular model known as recurrent neural network, or RNN. We will talk about this two models. So CNN is usually applied for image processing solutions, and recurrent neural network usually applies for text processing or the task that we discussed last time, something called sequence labeling. One common binding pattern, if you remember from my last lecture about the dependency between the input data points. Yes, so the so again CNN and RNS prediction plays a role in that, and both are capable of doing this. Usually, the CNN talks about spatial and temporal depend relations. Spatial and temporal data points relation is explored, and recurrent neural network is, as I said, is explores sequence labeling. So data sequence, it can process data into sequence. So data sequence dependency. Plus dependency between the sequence of the data. So both can. So let us say we are doing a digit identification system, and we want to classify a digit given in an image size of say 8 cross 8, or let's make it bigger, 20 cross 8, 28 cross 28. Let's say some image is given as 28 cross 28 image, something like this, pixelized image. And our task is, if we do this in a traditional way, let's first imagine the traditional way of doing it. So now in our context, traditional approach is MLFF or SVM. I use word traditional to refer to this kind of model. So what we do is we draw a multi-layered feed-forward neural network with hidden layer and some output layer. And we believe that one hidden layer is sufficient. So our network architecture would be like this only. Imagine the fully connected network. I don't want to draw so many arrows, but something like this, right? Can someone quickly tell me that what will be the number of neurons in input layer? Or how do you calculate the number of input layer neurons required to identify digit defining 20 as plus 28. As Priyank has rightly said, you need 28 cross 28 input layer if you do not do anything. And we can directly see that 28 cross 28 is a huge number of input, right? So many input layer neurons are required. And how many neurons you require for output layer? If you are doing 10, yes, Priyank says 10, 0 to 10. Since you want to predict 0 to 10, put 10 bulbs there, and for any digit, one bulb will go uh, on to detect that particular digit. So 0 to 10 neurons. Every neuron is one bulb in case of binary. You can further optimize it also as 10 digits can also be encoded by 4 neurons or 4 bits. So in that case, you need to do multiple neuron switching. But let's say it is 10, that only one neuron gets switched for any given input. And then you use some formula to average out between the input layer and output layer and find out the hidden layer neuron. There are many guidelines and heuristics for that. And then you train. And then you believe that your hidden layer function is capable enough to predict this mapping from input to output. That was traditional way of doing it. Now, we know that 28 plus 28 is a lot of dimensions and we want to reduce it. So what you would do? How do we reduce this number of dimensions? One way is do some feature engineering. So instead of passing every pixel, do some image processing and pass shapes. Maybe you can break down the image into some shape, straight line, curve, this curve, slanted line, this slanted line. You can divide the input image into this 5 categories. Category 1 is a standing line, or maybe 6 category. Category 1 is slipping line. Category 2 is standing line. Category 3 is C. Category 4 is inverted C. Then slash and backslash and something like that. If you can imagine other things, that is also fine. So you can do this kind of feature engineering, and then instead of passing this 28 plus 28 pixel, pass just this, so that you need to pass less dimension and more relevant information. Right? We talked about this when we talked about dimensionality reduction and other models. We said that we want to pass more relevant information to the machine so that machine can get trained easily and rapidly and better. So this is one way doing the feature engineering. And when feature engineering does not work, or if you still want to reduce, you can do some dimensionality reduction technique also. That is PCA, LDA, etc. And you can pass the less dimension. This is what people used to do earlier. But now in deep learning, we say that our model is capable. If you read this again, we say that the network can learn important features and make accurate predictions. So we say that now we don't want to do this feature engineering and all that. We have processing capabilities, we have space. So our model will uh, do this for us, and model will learn the features. So what you do? So there they introduce the concept of convolutional layer. So what do I mean? Let me give you a very crude example. That if you want to figure out is there any C-shaped curve in this image or not, how would you do this? Visual inspection, right? We are doing it with visual inspection, but more proper for more proper visual inspection, what you would do is you would put a slider like this. You will put a slider like this, and you will move the slider from left to right. You will move the slider from left to right and see that whether you are getting any curve or not. Does this make sense? This is the key idea. If you got this, then you got the CNN. Do you understand what I'm saying? So you are given a this is a very small image that you are seeing on screen, but let's say we have a very huge image and we want to figure out is there any shape like a straight line or curved line or slanted line or triangle or rectangle. Are there any shapes like this that we want to figure out? So what you do is you pass a slider through the image, and in slider where only you can see only this much area when you slide it. So this is visible area, and everything else is hidden. And as you pass, you will notice that whether you get a curve in the path or not. So that kind of slider you can pass, and this slider is known as convolution filter. Similarly, you can pass a second slider of this kind and move that slider on vertical line, on vertical dimension, and again try to capture the shape that you are seeing in between. So for example, when slider is here, the shape you are seeing is something like this. So you see that I have observed an X. So pass slider from top to bottom. So this is how you cut out on the input. Instead of looking at the entire image in one go, you pass the image through this kind of filters, which we call convolutional filter, and look at the things that you can see during that visible area of within that visible area of the filter. Then move the filter again to the next point and again see what you see in the image and so on. Right? So this is what filtering do out of it, and you don't see the entire data point, but you just sample something from the data through filtering process. So that's why the filters are, or that's what filter do. And with this, you can reduce the size of image. So instead of, so first step of CNN is called convolutional layer. So you give this again the input data point, the number 8 that we are talking about. The input data point first goes through such bunch of filters, which we call convolutional filters, or which is known as convolutional layer. So every filter means a specific feature, right? So if a horizontal filter might be looking for horizontal line, vertical filter might be looking, sorry, horizontal filter might be looking for horizontal line, and vertical filter might be looking for vertical line. Similarly, you can have filter for C shape, you can have filter for D shape, and so on. If you want to go a bit more in detail in the filter, let's try to do something like this. So let us also put a pixel value on this image. Let's say 100, 20, 30, 40, 80, 60, 40, 120, 50, 70, again 60, 50, 90, 80, 60, and so on. See, this is the input image in context of number, and you want to pass it through filter, it will be something like this. So filter is, let's put the first filter. So let's say my filter window is of size 9. So I have given a 3 cross 3 filter. So whatever I see within this, I can do some multiplication. Now, if I want to look, if I am looking at only horizontal line, then my filter will be something like this. This will be my filter. So I will multiply all these numbers by my filter value. So first column is multiplied by all 0, second column is multiplied by all 1, third column is multiplied by all 0. So what I'm looking at is is there any horizontal line in the middle? So that will be the output. So I will sum up all the values, and it turns out to be 60 plus 50, 110. Everything else is multiplied by 0, right? So this was the input that I have seen. 100, 20, 30, 60, 40, 120, 60, 50, 90. So do the bitwise multiplication at every point and write down the sum. So there is sum is 110. So after this filter, I can say that within this first 9 pixel or this 3 cross 3, first 3 cross 3 block, the strength of the horizontal line that I can see is 110. But that is only at one region, right? I have not explored the entire image. So what I will do is I will move the filter a bit left side. It can be one stride, two stride, all these are hyperparameters that we can control. So next is move the filter to one side and get another answer. Answer for this was 110. Similarly for other figure, 30 plus 120 plus 90. That is how much? 240. So for another, the answer is 240. Similarly for third, the answer would be something else, and so on. So I will have a smaller representation of image where every cell is the answer for three cross three filter process. So you process 3 cross 3 data through a filter and you put answer in a cell. That is convolutional layer. So this is the answer that you get at convolutional layer. And as I said, there can be many such filters. One can be horizontal filter, second can be vertical filter, one can be color filter also, R filter, G filter, B filter, and so on. Also, to extract the important things from image, you need this kind of information. So that is also part of 7th semester where you will learn image processing. So then second is filter processing. Now once this convolution layer is done, you can further reduce the size of input to a layer called pooling layer. We do not have sufficient time to talk about pooling layer today, so I will not discuss about it in detail. I would just say that pooling layer will reduce the size of data further by selecting largest from this or selecting average. that the data size can further be reduced. So it can be max pooling or average pooling and all that. And then you have again bit representation of the image which you flatten out. So instead of four filter, now flatten everything into one input row where all these things are lined up, and the number of dimensions will be much less than what we had seen earlier. And then after this, apply your traditional MLFS on this data point and train the system. Right, so this makes a complete convolutional network, and understand that this can be any number of, you can put any number of convolution layer and pooling layer. If you have sufficient processing capability, put any number of convolution and pooling layer before you do the final multi-layered feed-forward network. Yes, so this is CNN. We'll stop today here, and we'll talk about the recurrent network in next lecture. And in this coming week, Saturday, we'll also do a lab on this. Right? So go through it, go through the online materials available also, because we are doing it very quickly. So refer to the online blogs like Towards Data Science or Machine Learning. There are a number of articles which will give you the intuition about CNN and RNN. My expectation from you in this semester is that you should be able to write at least some basic vanilla program of CNN and RNN and understand the underlying philosophy. Right, so with this, we'll end. We'll not take questions today because it is already time. If you have any questions, we can discuss it next time. I will end here. Thank you.